So in the first part of this question, we're given the fact that the nth term, which means every term, depending on the value of n, is given by the formula 100 minus 3n. And remember that n clocks up from 1 and clocks up by 1 each time, right the way up to n. So if we just want the first three terms, we need to shove in n is equal to 1, n is equal to 2, n is equal to 3, and see what values we get. Okay, n is equal to 1. We get 100 minus 3, which is 97. So I'm expecting this to be linear. And once we've got the first drop, we can then predict the next answer. So n is equal to 2. We get 100 minus 6, and this is 94. A drop of 3. I am predicting the next answer will be 91. Let's just prove it right. N is equal to 3. We get 100 minus 9, and indeed we do get 91. So we subtract negative 3 every time. That's not part of the answer, but it's all part of our knowledge of this series, because we're going to be asked another question. And those are your answers. Okay, now part B. Work out the first term of the sequence that is negative. Well, you can solve this by counting on your fingers, but it's not a very good method. It'll take a long time. It's much better to do some algebra and work this out. So let's have a go. So what they're saying is that a certain value of n is such that 100 minus 3n is less than 0. Remember that 100 minus 3n is the value of all of the terms of the series, depending on the value of n. So if we can work this inequality out, we won't have to resort to counting on our fingers virtually to find out what value of n first of all produces the series answer, which is negative. This, remember, less than 0 is a perfectly good mathematical argument for a number being negative. So let's see what happens. We, again, rather like an equation, we have to put n's on one side and numbers on another. So I'm going to put n's on the right-hand side and numbers on the left-hand side of the inequality sign. So 100 can stay. To move the 3n, again, just like an equation, we can add 3n to both sides. That will eliminate it from this side, and it will appear over here as positive 3n. So 100 is less than 3n. Because we've got no more terms to move, we have to unglue 3n. And the only way to unglue 3 times n is divide through by 3. So I get 100 over 3 is less than n. The 3's having cancelled. So let's just write this the other way round. Now, you can see that the inequality's open mouth is looking at the n. So if I'm going to write the n first, the open mouth must remain open to the n. So n is greater than 100 divided by 3 is 33.333. So what's the next number up that's greater than 33.33, but remember n has got to be an integer. And the answer is that n must be equal to 34. At column 34, this series goes negative, and that is your answer.